welcome back to the channel. So today we are going to discuss the different terminologies which are there in Spark and which are important for the interviews, right? So today we will be covering around 16 to 17 terminologies, and in our next session we will cover few more, right? So let's start. So in our previous video we discussed about the Spark architecture. So if you have not seen that video, you can go to my YouTube channel and you can view this video, right? So let's start with the today's video. So the first terminology which is really important is job. So what is job? A job in Spark is the highest level of unit work triggered by an action. Okay, so with this we understood that a job is created when an action is written on what data frame, right? So whenever we write df dot any action, so that action can be anything, right? Collect, count, so, or anything, right? So it will create a job, right? It will create a job. It encompasses the entire computation Spark will execute on a dataset. So basically we write different transformation on a df, right? And on a df, if we call any of the action, it will basically create a job, right? So that is what the job is. If we call an action count on a RDD, Spark create a job specifically. Okay, if we are calling count, then it will basically count the number of records are there in the RDD. So these are the different type of actions which are there, which will create the job basically, right? So this diagram which is here is really important. So here we have the Spark application, and Spark application can have multiple jobs basically, right? Multiple jobs based on the actions which are there on the Spark application, and each job can have multiple stages. So we'll discuss more about this, how the stages are decided, how many stages would be there. But as of now you can like see this flow: application, then job have multiple stages, and each stage can have multiple tasks, right? So this is the flow basically. So df, then job, then stage, then action. I think in a lot of like online assessment of a data engineer role, we get such kind of question in a MCQ, like what is the flow in which these things are written, right? Job, stage, and action. So sorry, task, not action, this should be task, right? So I think you understood, like a job is created when an action is triggered on a like computation, right? And a Spark application can have a multiple job. You can answer like this. Now let's discuss about the stage. A job is split into multiple stages. So here we saw that this job 2 has 3 stages, right? Each representing a set of tasks. So if you see this stage has set of tasks: task 6, task 5. Similarly, stage 3 has only one task. So each stage has a set of tasks that can be executed without shuffling data. So task basically a unit of work, right? So it doesn't need the shuffle of data. Stages are defined by transformation that cause data movement, like group by, join. Okay, so basically transformation are of two type, right? The narrow transformation and the wide transformation. So for a narrow transformation, okay, like we'll discuss about narrow and wide in a bit. So before that, let's understand this example, then I think the things should be clear. So here is the example which will help us to understand the stage basically. So what here we are doing is we are reading this data.csv, we are creating the df, and on the top of this df we are applying this filter. We are saying that the age should be greater than 0. So this is basically a narrow transformation. Why it is narrow transformation? Because there is no shuffle of data. This is simply a filter, right? So I think we covered this question also. What is narrow transformation? So narrow transformation doesn't require the shuffle and can be computed within a single stage, right? Within a single stage. Got it? So basically the number of stages depend on the type of transformation which we are applying, right? So narrow transformation can be done in a single stage. That means for the wide transformation we can have multiple stages, right? Multiple stages. Got it? So here if you see map, this is also a narrow transformation because there is no shuffle of data is needed. It's just the mapping of the data in the RDD, right? And a group by age. Here we are doing group by on age. So here the shuffle is required, right? So that's why it is a wide transformation basically, and for this one altogether we need a different stage. Got it? Okay, so now let's understand this, how to decide the number of stages. So in a Spark UI also you can see, basically you can visualize for a given job how many stages are there, right? So here if you see two stages are there. Stage 1 is for the filter and map, and the second stage is for the group by, right? We can view the stage breakdown of any job by checking the Spark UI. So on a Spark UI basically you can check a DAG visualization tab provide a, like on a Spark UI when you see there you will have a button to see that, right? Based on the transformation basically we can check the number of stages which are there. So I think we understood the stage also, right? And we understood the narrow and wide transformation. So I think we have covered this also, these two. So wide transformation is nothing but the transformation which need the data shuffle, right? So here the group by key, reduce by key, group by, or basically the joins, right? So these are the wide transformation. Why, right? The difference between the wide transformation and a narrow transformation is narrow transformation doesn't need the data shuffle, wide transformation need the data shuffle. What do we mean by data shuffle? Data shuffle means we know that the Spark is a distributed system, right? The data is splitted or stored at the different node. So when we call a wide transformation, the data is shuffled across the nodes basically, right? So I think we understood this. So let's talk more on this. So we understood the how the Spark stages are decided. Now let's talk about the task, right? So a task is the smallest unit of execution in Spark, representing the computation on the partition of the data, right? So basically the number of tasks depend on the number of partition. So let's say if we have a 10 partition, so we can have a 10 task basically, right? Within each stage, Spark create multiple tasks. So basically if you see for each stage, here stage 1 this has 2 tasks, stage 3 2, here it has only 1 task, right? So it can have one or more tasks basically for each and every stage. So within each stage, Spark create multiple tasks, one for each data partition. So as I mentioned, number of partition equal to the number of tasks. Each task operate on the separate partition, allowing parallel processing of the data. So basically if we have 10 partition, let's say partition like this, and for each partition we will have task. So task 1, task 2, task 3, and all these things will be computed parallelly, right? That's why Spark is quite fast, right? So if the data is divided into the 4 partition, Spark will create the 4 tasks per stage to process them, right? And here we have the example again. For an RDD with 10 partitions, Spark create 10 tasks to process each partition in parallel within the stage. I think we understood very clearly what is the difference between stage, task, and job, right? So here we have the transformation and action. I think the above 3 has covered a lot of question we have below, right? So transformation we understood, like we can understood this very easily, that it is a lazy evaluation basically. Whenever we write a transformation and if we do not call any action, it will not get triggered, right? So this is how you can answer. Transformation or operation on the RDD or a data frame that create a new RDD, right? If we call, like if a transformation, if we have transformation 1, and if we call again another transformation, it will altogether create a new RDD and the data frame without executing them immediately. So we know that the transformation are nothing but the lazy evaluation. They doesn't get evaluated as and when we create them. So the different examples we can have is the map, filter, and all those things. So action, this also is very easy. So the action trigger execution of the transformation. So the transformation is useless until and unless we call an action. So it's like basically creating a function in the Python. So let's say if we create a def let's say sum, right, sum, we return a value as a plus v. This function is useless until and unless we call this function, right? The same way transformation is useless until and unless we call an action on it. So we can have a different type of action: collect, map, collect, and then collect, count, and then so all these things, all these are the different actions. And I think wide transformation and narrow transformation we already discussed. Now let's talk about the RDDs. So RDD is what? A resilient distributed dataset. What is the meaning of resilient? Resilient are nothing but it is like the meaning is fault tolerant. Distributed, this we know that the data is reside on the multiple node, and the data set, this is nothing but the set of data. Now let's discuss about the RDD. So RDD in Spark fundamental data structure. RDD is nothing but what? Spark fundamental data structure. It is immutable distributed collection of object that can be processed parallelly. So I think these are quite simple, right? RDDs are resilient, meaning that they can recover from failure. And this recovery is achieved with the help of the lineage of the transformation which is created by the Spark, right? uh, and if we take the example, if we load a text file as an RDD, each line of the file is treated as an element of in the RDD, and we can then perform the transformation like filter, map on each element. So let's see this example basically. So what we are doing is, here we are loading the sample.txt file using the Spark context, and this is called an RDD. And on the RDD we are calling the different transformations, right? And here we are calling the actions basically that will give the count of the number of lines or the words which are there, like the length are more than 3 in that, right? So this is what the RDD means. So this is how you can answer basically. It is immutable, and you can explain basically these three things, like what is the meaning of resilient. It is mean that it is a fault tolerant mean if there is a if anyhow we lost the data, we can basically recover with the help of the lineage graph which is created by the Spark, right? And it is distributed, and data set, we can say that it is a set of data, right? And we can give this example. Now let's understand what is the DAG. So DAG is a directed acyclic graph. So the meaning of this is directed acyclic graph. Now let's break down this. What is the meaning of DAG? Directed. Each transformation has a clear direction flowing one step to next step in the order they need to be executed, right? Now let's read this first and then we go through the example. You understood, right? Directed means a set of step, basically the order in which they needs to be executed. It's not like we execute this transformation and straight away we go to this, like, so we write something like that. We write df dot filter x greater than y, and then again on this we write the map, right? And then we write the group by, right? So it's not like we execute this and straight away we can execute this is not possible, right? We have to go in this way. So that is what the directed means. Acyclic means a graph has a no cycle, meaning that the transformation cannot look back to the previous stage, right? Ensuring there is a clear path. If this is a cyclic, if these things are cyclic, then the computation will be wrong, right? And there will be difficult to track the data basically, because the data is here the distributed, right? So this is what the acyclic mean, that is there is a no cycle between the among the transformations. Graph, it is a collection of node and edges. So collection of node and edges, where node represent the data transformation, so data transformation like map, filter, and edges represented the dependency between these transformations. So this dot we write, right? for after each and every transformation. So this is the dependency, and this so that is basically called as node are nothing but the transformation. So these are nothing, the filter map are nothing but the transformation, and this the edge represent basically the dependency among the transformation. So this dot like one after the other which we write. So let's see this example. When performing a sequence of map, filter, reduce, transformation, Spark builds the DAG to represent the dependency among these operations, then optimize the execution, right? So this is how we can answer basically what is DAG. Now let's see some questions on the Spark architecture. I think this we have covered in our previous video. So if you have not seen our previous video, I would like to tell you that we have already created this video, so you can go and watch this, right? So let's go through them. So this is the Spark architecture, right? So here you can get the question on what is Spark driver, what is Spark context, what is Spark like cluster manager, what is worker node, what is executor, right? And the task we have already discussed. So we can just go through one by one. So what is driver? We know that the driver is the building block of it. It is the master basically, right? So we know that the Spark architecture is the master and slave. So driver is nothing but the master of it. So driver program is the main application where the Spark context is created. So here if you can see within the driver we have the Spark context, and responsible for the creating the job, stage, task, coordinating the execution basically. So for a detailed explanation of this Spark architecture, you can go through my previous video, right? When running a PySpark script, that script itself is the driver program that initiates the job. I think we understood that in our previous video itself, that Spark job, in this we have the main method, and main method get executed into a driver, and that is what the driver program is, right? Spark context, we know that it is basically help, it sends the code to each and every executor, right? And it stored the different variables and everything, right? So we can tell like this: Spark context is the entry point of the Spark functionality, and connect the application to the cluster basically. So how it connect is, here if you see Spark context, what it does is it gives the code or the task which needs to be executed from each and every executor, right? It sends the code basically, right? So this is how we can create the RDD with the help of Spark context. Worker node, we know that worker node are the machines basically where the executor reside, and it runs the executor. They perform the actual data processing and computation, right? And uh, in a yarn cluster, worker node are where Spark executors are launched, executing tasks sent by the driver. I think this is really easy to understand. Within the worker node we have the executor, right? Executor does the job which are given by the driver program, right? And then we can have this cluster manager. So this is quite easy to understand. So cluster manager basically coordinate between the executors and the driver, right? So this is how we can give the answer. So the cluster manager allocate the resources for the Spark application, and there are different type of cluster manager like yarn, mesos, standalone, kubernetes, and all those things, right? Then we have the executor. Executor are the process launched by the worker node responsible for executing tasks, storing the intermediate data in memory. I think this is quite easy to understand, that executor are the building blocks, right? They are nothing but the executor have the multiple tasks, they execute the task and they give the answer to the driver basically, right? So, and then memory, what is memory? So the memory in Spark, like we know that the Spark is in memory processing, right? That's why memory become really important. So it is nothing but the RAM basically, right? So the memory in Spark is used for storing cache data, broadcast variable, managing the task execution. Adequate memory helps Spark optimize processing, right? So if we cache the RDD in memory, Spark store it on the executor memory, reducing the computation for a repeated action on the RDD. So basically we have the cache also, right? That is not present into the Hadoop map reduce. So we calculate the intermediate result, and that is get stored into the memory, right? So for each and every executor we have a memory. So for executor, let's say if it has a 4 core and 16 GB of memory, so this memory which is there, that is where the broadcast variable or anything which the job should store, it gets stored over here, right? And what is core? I think this is also really important. So the core basically tells how many number of parallel tasks which we can execute, right? So the core are the CPU unit assigned to the executor. So as I mentioned over here, executor has two things. One is core, second is RAM or memory, right? So if we say that the executor is having 4 core and 16 GB of memory, that means the 4 tasks can be done parallel. So the parallelism is nothing but the number of core, right? So I think we have covered the 16 important terminologies which are really important. So you can basically go through all of them and you can answer the things accordingly, right? So let's meet in our next session of this key terminologies in Spark, where we will be covering uh, few more terminologies like JVM, broadcast variable, lazy evaluation, checkpointing, cache and process, and fault tolerant, right? And I will be adding few more in that. So okay, then let's meet in the next video.